Hello, today we will be solving the Artisanal Sudoku volume 232. And the first puzzle we are looking at is called Mixed Use, and it is estimated to be a 3 out of 10 difficulty. So let's get right into this one. Let's look at the rules over here. Clones, blue shade regions contain the same digits and same relative positions. So what does that mean? Let's say it as a 1 in this cell right down here, then it means that there should also be a 1 in this cell over here because they are in the same position in these blue regions over here. Arrows, the sum of the digits along an arrow is equal to the digit in the connected circle. And let's just have a look at this circle over here. Let's say this one was a 3 and a 6. That would mean the digit in the circle should be a 9 because that's the sum of 3 plus 6 is 9. Let's see, digits still separate by a white dot are consecutive. White dots here, it means if this one is a 1, then this white dot would point to a 2, and the same would be up here. And digits in cells separated by a black dot have a 1 to 2 ratio. So, for example, these two black here, let's say this one was a 3, that means this other digit here needs to be a 6 because they are in a 1 to 2 ratio. And then, of course, a 9 cannot be here because there's no 4.5 or 18 that can be in a digit. And yeah, those are the rules. So let's get right into this solve. And the first thing we can look at is probably these black digits down here. Since there are 3 digits that needs to be in a 1 to 2 ratio, it only means that it will be one of these 4 digits, 1, 2, 4, and 8, because those are the only one that have more than 2 digits in a 1 to 2 ratio. The other one would be a 3, 6 pair, but let's just put these ones in here. And of course, the middle one cannot be a 1 because that would mean both of these should be a 2, and the same with an 8, both of these will be a 4. So we can just remove those 2 from here. And let's just input the same digits over here because they're in the same relative position, so we can just copy them. Let's see, this digit down here cannot be an 8, because if that was an 8 here, we would have a 4 here because of the 1 to 2 ratio down here, and we would get a sum of 12, but that's not possible. So let's just remove the 8 from here. And this one can also not be a 1 because this one should be a consecutive digit, which would be a 2. And for a 1 to 2 ratio pair, this would also be 2. Same for this one over here and this one up here. So this one cannot be a 1 at least. Let's see. These 2 digits here, they are in the same relative positions, and they are in a 1 to 2 ratio, which means these needs to be a 3, 6 pair. Which means this digit up here in the circle is a 9 because 3 plus 6 is 9. And now we know this digit here that is in the 1 to 2 ratio will need to be a 1, 2, 4, 8 pair because it already sees the 3 and 6 from here, so we cannot have the same 3 and 6 pair over here because they are taken. And now this one can of course not be an 8 because 8 plus 1 plus 2 is way too much than a 9. So let's just give this one a 1 to 4. And if this is a consecutive digit, it needs to be a 1, 2, 3, 4, 5, but we cannot have a 4 here because there's no 3 or 5 over in this digit over here. And now this one also needs to be consecutive with the 3, 6 pair over here, which means this one cannot be a 3, of course, and it cannot be a 1. So this will be a 2, 5. Which means this one up here needs to be a 2, 5. And it cannot be a 5, because if this is a 5 here, we'll have a consecutive digit with 4, and that would already give the 9, but the arrow goes all the way down to the next cell, which means it will be more than 9. So this one we can write in a 2, and consecutive is 1 and 3, and this one 1 to 2 ratio will be a 2. Now we know this one down here is consecutive with a 2, but it's not 1, so this will be a 3, will be a 4. We can write in same over here. A 3 and a 1 to 2 ratio will always be next to a 6. So now we have 1, 2, 3 up here with a 9. It cannot be 8, 1 pair, it cannot be a 7, 2 pair, 6, 3 pairs already taken. So this will be a 4, 5. And we will have a 7, 8 pair up here. And we know this digit here is a 3 based on the cloned cells. So this one will be a 1, 2, 3 pair, which means it's a 6. Now we know this cell over here cannot be an 8, because if that was an 8, this needs to be a 9 and needs to be a 1 here, but we already have a 1 here that sees that one, so this will be 4. And based on the black 1 to 2 ratio circles, this will be a 4, 2, 1 cell. And which means this one will be a 3, and this one will be a 9, because we already have 1, 2, 3, 4. So the lowest number here will be a 5, which is also the largest it's allowed to be. So let's see, these two here will be 5s because they see the 3s already. This one will either be a 2 and 8, but it already sees a 2 over here, so this will be an 8. This one is always next to a 2 in a 1 to 2 ratio. So let's see, the ones in the middle square will not be in this row, or this column, because it sees the ones from here, and cannot be in the 5th row because it sees the one from here, so there will be 1 here. Consecutive digit next to 6, but we already have a 5, so this will be a 7. Let's see what else. Okay, we know the 2s cannot be in this column, or this row. 2 will be over here. We know the 2s cannot be in any of these cells, so 2 will be up here, 2 will be over here as well, based on these 2s down here. We know the 3 can only be in this cell up here. Let's see. Alright, we know the 1s cannot be in these cells and neither these cells, because it sees all these 1s over here, so there will always be a 1 in this little cell here. Let's see. For the 3 maybe? No, let's see the 4. Right, we know the 4s cannot be near these cells over here, so we can write in a 4 here. We know the 4 can only be in this cell based on these 2 4s, and can only be in this cell based on these 3 4s over here, and it will give us a 4 here and a here based on the other 4s. Now we know this one will be an 8, 9 pair, the last remaining digits in the row. It already sees an 8 here, so this will be 8 and 9. The 8 can only go in this cell over here. And the 5 in this box here can only go in the cell to the left here. Which means the 5 in box 7 can only go in the middle cell. And for the 6 in box 8, these 3 cells are already taken. And we know in column 1 we are missing a 6 and a 7. The 6 is already down here, so this will be 7, this will be 6. We're only missing a 9 in this box. Now we're missing a... Let's see, where can we get a digit? We're missing a 7 in row 7 over here, which only has one possible one. We're missing a 7 and 9 in row 3. 7 is already here, so this will be a 9, this will be a 7. We know the 9 can only be in this cell here. The 5 is already seeing this cell, so this will be a 8, this will be a 5. 8 will be down here based on this cell here. This one will be a 9, we're only missing 9. We're only missing a 7 here. Now the 8 sees those 2 cells here, which means it will be in the middle. Now we are missing 6, 7, 7, 9. 1, 3, and 6. We can get the 5 in this box up here. What are we missing here? We're missing the 6 up here because the 7 and the 7 here. And now there's only a 1 free pair here. 1 free pair here. And we're missing a 1, 3, 8. Maybe the 5 in this box here already sees these cells, so it can only go in the middle. 1, 2, 3. It's a 3 and 8 pair, but we already have a 3 here, so this will be an 8, this will be a 3. 1 up here, 3 here. It's only missing an 8. So now we are missing 1, 3, 6, and 9. The 1 and 9 already here. We already know the 1 is here, so the 1 cannot be in any of these cells. The 9 cannot be in any of these cells. And now we're missing 3 and 6, which means 6 and 3. There we go. That's the first one, mixed use. Let's just head on to the next one, Setback. Estimated to be 5 out of 10 difficulty. So let's have a look at the rules here. Standard Sudoku rules: region sum lines. Box borders divide each blue line into segments with the same sum. So what does that mean? So for example, these 2 blue cells over here are crossing the border right here to box 7 and box 8, which means the 2 cells here, whatever these will be, like a 1 and 6, which means the sum is 7. That means these 2 digits over here will also need to sum to 7. So they can be a 3-4 pair, for example. And then quadruple circles, a digit in a white circle appears in at least one of the 4 surrounding circles. So, for example, the 2 and 3 down here again needs to be in any of these 4 cells over here. So let's just start this one. I already see this circle over here with 4 digits, which means there can only be those 4 digits in the 4 cells. So 2, 5, 7, and 8. This cell here can only be a 6, 7, 8, or 9, because we need to have at least 3 digits over here. The minimum sum is 1, 2, and 3, which gives 6. And then of course it can go all the way up to the 9 up here. We already know this one cannot be 6, 7, or 8 actually. And And why do we know that? Because the 1 needs to be, it cannot be in any of these 4 cells here, because this will be 2, 5, 7, and 8. So the 1 needs to be in any of these 5 cells here. And let's try writing a 7 in this cell here. We will need to have 3 digits add up to 7, which means it will be 1, 2, 4. The same goes for this blue line up here, because it goes to into the same digit over here, so it needs to have the same sum as the single cell here, which means it will be a 1, 2, 4, 1, 2, 4. And now where do we put the 1 in the middle box if both of these digits are 1? It cannot go in any of the cells in the middle box. So we know there will be at least one of these free cell free cell line that cannot contain a 1. Because if there's a 1, 2, 4 here, the 1 needs to be in these 2 cells down here, which means there cannot be any 1 in the top blue region sum. So now we know at least one of these cannot contain a 1. And that will mean the lowest sum is 2, 3, and 4, which is 9. So we can already type in a 9 here. Now we also know that there needs to be an 8 in any of these 4 digits here. It can obviously not be in the 9 cell, and it cannot go in any of these 2 cells here. If this is a 9, if this is an 8, and we need to sum to 9, we cannot add 2 more digits to it. So this is an 8 over here. And the same goes for the 7. We cannot have a 7 here and add a 1, 2 pair up here. That will be 10. So this will be a 7 up here. Now we know which line the 1 is in. It already says right here in the circle, there needs to be a 1 in any of these 4 cells, these 2 occupied. So this one will contain the 1, and this one down here will be the 2, 3, 4 pair. And now let's have a look back at this middle box again. Now we need to figure out where can the 3 and 4 be in this box. They can obviously not be in the 4 digits here. And now we know the 3 and 4 are already in this row. So these three cells are taken. All of these 4 cells are taken. So they can only be in those 2 cells down here. Which means the 3 remaining cells will be 1, 6, and 9. And now let's have a look at this line up here. Adding up to 9 with 3 digits. And we need to have a 1 in it. It can either be a 1, 2, 6 pair or a 1, 3, 5 pair. But we already know that there cannot be any 3s or 4s in this on this line, so it will only be 1, 2, and 6. Which means this one down here cannot be a 1 and a 6, so it's a 9. Now let's have a look at these 4 digits here. We know there will be a 1, 2, and a 5 in 3 of the 4 cells. We know the 1 cannot go in the row down here, same for the 2. So these 2 cells up here will be the 1 and the 2. Which means this one cannot be a 1 and 2, this will be a 6. So now we have 1, 2, 3, 4, 6, 9, so this one will be a 5, 7, 8 pair. Now we can do the same for the 2 and the 3 down in these 4 cells. They cannot be in this line, so there will be a 2 and a 3 in these 2 cells here. Which means this one cannot be a 2 and 3, this will be a 4. And we can do the same over here, 5, 7, 8. We know the 5 needs to be in either of these 2 cells, so this one cannot be a 5. Now we also know the 2 needs to be in any of these 4 fields, so the 2 needs to go here. The 1 needs to be in any of these 4, so the 1 needs to be in this one over here. Now let's have a look at this region sum line down here. So let's see, what's the least amount of sum this one can be? This will be a 12. And the max sum with a 2 and a 3 is also 12. So we know these two cells down here will be in 5 and a 7, because they will give 12, and this one will need to be a 3 with a 9 as the maximum. So it will have the same sum as the 5, 7, and will sum up to the 12. What can we do from here? Maybe these three sums are very interesting. Let's see. We know all of these threes, all of this box will sum up to 45, because 1 plus 2 plus 3 plus 4 all the way up to plus 9 will give 45. And we know that the same goes for these three or 6 digits. They will add up to 45. So let's see, what's the magic we can make these one? This will be a 7-8 pair as the maximum, which will give 15. This one already sees 8, 7, so the maximum is 15 here as well. And the maximum in this box is also 15, so that is exactly 45. If we put all of these 6 digits to the maximum values, they will give the value that we need in box 9. So this one, we will know these will be a 6-9 pair, and these two up here will be a 7-8 pair. So now we also know that the 6 and the 9s already see these 5 cells here, so they will go in any of these 4 cells, and we also know they will contain a 4 and a 5, so we know this one will be a 4, 5, 6, 9 digits. Now we can see the 9 is already taken from over here. So let's see about the 8 in this box. We know there can be no 8 in any of these fields. We already have an 8 in row 7. So we know the 8 can only go in column 7. Somewhere over here. Which means this one can never be an 8 now. This will be a 7. What else? We also know there can only be a 7 in any of these two fields over here, which means this one can never be a 9. Because 9 plus 7 is already 16. We can only sum up to 15. So there will never be a 9 here. There will always be a 9 in this cell, because we already have the 4, 5, 6 only in these 3 cells here. So now we know we need to add up to 15. So we cannot have a 6 here, that will be 15 already. We'll need a 1 or 2 in this one. So they will add up to 6 together with the 9. Get a 1, 2, 3, 4 here. The 2 sees this row, the 3 sees this row. We will have the same here, 1, 2, 3, 4. Now let's see about the 9 in box 4. Where can the 9 be? They cannot be in any of these digits. They cannot be in row in column 3 or column 2. And it cannot be this digit, because it needs to be the same sum as this single field down here, which obviously cannot be a 9 because the 9 is already in this box. So we know this is a 9. Now we know this will be 6 and this will be a 9. So where do we go from here? Let's have a look at maybe down in this box over here. You can see 8 can only go in any of these two cells. We can get a 2 up in box 1. It cannot be any of these cells. 2 is already over here, so it takes these 2, and then the 2 is from down here. So we'll have 2 here. And we also know there needs to be a 1 and a 2. So this one will be 1, 2, and 8 because we have a 1, 2 pair over here. Wherever we put the 1 and the 2, we also need to put a 1 and a 2 in any of these 4 cells here. So if we have a 1 in this cell up here, we need to put a 1 in each of these 2 cells, which means this can never be a 1. Same goes for 2, we need to put 2 will be here, we need to put a 2 in any of these cells. So there can never be a 1 and a 2 in any of these 6 fields, which means this will be a 1, 2, and then we already know there needs to be an 8. So it would be 1, 2, and 8. Let's just remove these outlines. So now we know there will be a 3, 4, and 5 up here. And we know this one will be a 3, 7 pair as the last remaining digits. So this will be, we need to add up to 15. We have 10, so we need to give it 5 more. Just gonna clean up the digits here. Okay, now we know we need to add up to 15 here. We have 13, so we need a 2. Now we have a 1, 2, 3 in these 3 digits, so we know this one down here can never be a 3. So this one will be a 7, this one will be a 3. Now we can see where the 7 goes in box 3. Cannot go in these 2 columns. This one is already taken by the 1, 2 pair. And we know the 7 from row 2, so it needs to go up here. Now let's see over here. We'll get a 1, 4, 5 pair. Last remaining digits in the row, which means this digit up here needs to have the same sum. So this one will also be a 1, 4, 5, and this is the 4 already. So this one will be a 1 or 5. And now we can see these 5 cells here. It will be 1, 2, 3, 4, and 5. So we know the last 3 remaining cells needs to be a 6, 7, and 8. And down here, we also have 7 can only go in the cell down here. The 8 can only go in the cell down here, as we knew from before. So 6 can only go in this cell, 7 over here, 8 here, 6, and so on. The 8 in this box can only go here, which means this is 1, 5. We get a 1, 5 here. 1, 1, 2. This one will be a 3 and a 4. And the 6 in box 1 can only go in this field up here, which means this one is also 1 and a 5. So now we have a 1, 5 pair here. This one can only be a 4. We have the 1 and then 2 from here. So this one can never be a 1, it will be a 5. This one will be a 1. These two will have the same sum, so there will be 1s. This one is 5. 6 and 1. Now let's see, the 8 in box 3 cannot be in any of these cells. They will be right here. Same for this 8 up here. We'll need a 7 in row 3. They cannot be in any of these fields. And the 7 from here sees this one. So we'll need a 7 here. Now we have a 3-4 pair in these two cells and these two cells. So it means the 9 in column 5 needs to be right here. And now the only remaining digits are 3, 4, and 5. And we have the 6 in box 3 needs to be here, and the 9 needs to go in the top corner. And now for this little region sum line. We know this one can never be a 5, because the least amount of the minimum sum will be 6, which is more than the 5 up here. So now we know these two are the 3 and 4s. This one will be a 5. This one here will be a 5. Now we know the minimum sum of these two cells here will be a 3 and a 1, which gives the 4 up here. So let's just input those and just add the remaining digits. There we go. Let's just head on to the last puzzle, 44, with the estimated difficulty of 10 out of 10. So let's have a look at this one. Alright, so the rules for this one is dynamic fog. Correctly place digits, clear fog from their own cell and possibly other cells. What does this mean? As we can see on this entire Sudoku board, everything except for these 3 fields are completely gray, which means we do not know anything about any of these cells over here. So when we input, maybe this cell needs to be a 4. If we input a 4 here, it would clear up maybe some fields around it, maybe some fields in one of the corners. It will give us some more information. So all we know as of right now, there are these 3 cells here, which we will get to in the other rules. The cage rule. The sum of the digits inside each cage is equal to the small number in the top left corner, and digits cannot repeat within a cage. Cage sums are in the leftmost cell in the highest row reached by the cage, and all cage sums are given. That's quite a lot, so let's go through it step by step. So let's have a look at this little cage right here. We know there's a digit in the top left corner, which will give the sum of the digits inside the cage. So this one will be sum of 44, which we already do know some things about it that we'll get into when we solve it. But all the digits that are inside this cage, it might go something like this. We'll know that all of these digits here will sum up to 44. And then we also know that the sum, or the cage sum, will be in the leftmost cell in the highest row. So of course this one cannot go any higher, because now the highest row will be row 3. So the sum will need to be up in this field somewhere. And we also know that it cannot go somewhere over here, because it needs to be the leftmost cell in the top row. So if this was the cage, then we would have the sum in this cell over here. So we know a bit about these cells already. And now for the ren-ben lines. Purple line contain a non-repeating set of consecutive digits in any order. lines do not branch or overlap. So let's have a look at a Renban line. So this might be a Renban line in the Sudoku. We know there are 5 digits. They could be like a 1, 2, 3, 4, 5 pair. Because they are all in a consecutive order. We cannot have a 1, 2, 3, 4, 6 pair because there will be no 5 to be consecutive to the 6. Then we can obviously have like the 2 up here, the 3 over here, 5, 6. It doesn't matter the specific order on the line. It just needs to be the specific order for all the digits on the line. The 2, 3, 4, 5, 6 pair. And that's all the rules there are for this puzzle. So let's have a look at this one. The first thing we can notice is that all of these 44 sums are very constraining. We know that all of them will be 8 digits, and all of them will be 2, 3, 4, 5, 6, 7, 8, 9. Because we cannot have any repeats in a cage, and we know the sum of 1, 2, 3, 4, 5, 6, 7, 8, 9 will give 45, and the only digit that needs to be retracted from 45 is a 1, so we know there can never be a 1 in any of the cages, and they will contain all the remaining digits from 2 to 9. So let's just go about maybe coloring in the path for the cages. We know this one will go one down. It cannot go to the side here. It borders all of these corners. So we know it needs to go down. We know it can never get up to row 4, never go up to row 3 or anything above. But for now we only know that it will go one down. We can do the same with this one and this one. Now we also know that all of these will be at least 8 digits. So where will this pink cage go? It cannot go back up because we also know this one is bordering all of the remaining cells. It can the cage will not go up or to the left or to the right. It goes down. Now where do we go from here? We cannot go into the green cage because we already know this one. All of these are 3 different cages. They all have their own sum. So we cannot branch into the cage to the left. We cannot branch into the cage to the right. So we need to go one down. The same with the orange one here. And we can even go one step further down here because we know this one will not branch into the pink cage either. So now in this box 6, where do we put the 1? We know none of the cages can contain a 1. So the only place the 1 can be is in this cell here. And now let's see. Now we also know the path of the green one. It needs to go at least to the left here. It cannot go into the pink. It cannot go down to the 1. So it needs to go one more step to the left. And now back to the pink cage. We need 8 digits at least. We have 3. So now we need to go down to the 4th digit. We cannot go into the 1. The 1 can never be in the cage. We cannot go into the orange cage. So we need to go 1 down. And now we can see this cage here. We know it is part of the pink cage because it crosses into the cell here based on the grid lines. So we know this one will be part of the pink cage. We know this cell over here, which is also part of the pink cage. So now we have 1, 2, 3, 4, 5, 6 cells in the pink cage. Now for the orange cage, we only have 4 cells. We need 8. So we know it cannot go into pink. We need to go 1 down. And now from here. So now let's see, where can the 1 be in box 9? It cannot be in any of the cages, so these 4 fields already taken. In column 7 we already have the 1 here, so these 2 fields are taken. We know based on the Renban line that these will be different digits, but consecutive. So that 1 cannot be down here, so we will have 2 1s on the pink Renban line. So we know the 1 cannot be down here, the 1 will be in one of these 2 cells. And now for the orange line, we need 8 digits at least. We have 5, and we cannot. Let's say we have the 1 in this field here. Where will the orange line go? We need 3 more digits. We can get 1 and 2, but where will we get the last digit? We cannot go into the pink cell. We know this one is not a cage cell because it does not have any grid lines. We cannot go into the 1. So that means the 1 can never be in that cell over there. So now we know the 1 will be in this cell over here. Now we can extend the green cage. We know it goes into the middle cell in box 5 and goes further down here. So we have at least 5 cells here. Now let's see, we have a different cage up here. Let's make this one red. The red cage. Let's have a look at the 1 in the middle box. It cannot be in any of the cages, and it already sees the 1 from row 6. So the 1 can only be in this cell up here. And these 3 cells here will be a 2, 3, 4 because we know there needs to be consecutive digits, and this Renban line cannot branch in any way, so we know it only goes 1 up, 1 down, and then down to this one. So there will be 1, 2, 3, 4 consecutive digits. Now where do we go from here? Now we can finish the orange one. So we have 5 cells, 6, 7, and 8. Maybe let's have a look at the 1 in box 8. We know it cannot be in any of these cells based on the other ones. We know these 2 are cage cells based on the grid lines. So there will be at least a 1 in any of these 2 ones. And now maybe for the green cage. We have 5 digits. We need 8 digits. We cannot go into... Can we go? No. We cannot go into this cell right here because this little box corner right here tells us that we cannot go into this cell. This is not a cage cell. So we know it needs to go either to the left. It cannot based on the red grid. So we need to go 1 down, which means the 1 can never be in this cell based on the 44 sum. So this one is a 1. Now the same with the other Renban line. This one will be 2, 3, 4 pair. And now let's see. Let's go 1 step further with the green one. 1, 2, 3, 4, 5, 6 cells already. So we need 2 more cells. We cannot go into the pink one. So we need, and we cannot go into the 1. So we need to go over here. And know this cell down here is connected to the grid as well. So this will be the 8 digits. We already have the 8 digits for the orange one. Now maybe let's get the 2 remaining one for the pink. At least we know it goes 1 down. It can go up to the cell up here, but then it also needs to go down here, or then it will need to go 2 down here, so at least we need to go 1 down. And now we know for the red cage, we have 4 digits, we need 8. The only path is to the left, and then it's part of this cage down here, so we will go 2 lines down as well. Now we have 4, 7, so we have 1 more digit. We don't know where the remaining one will be in any of these 4 cells for now. But now we can see where's the 1 gonna be in box 7. It cannot be in any of these 2 rows. It cannot be in the cage. It cannot be in the red band, because we already have 1. We will have a 1 in this magic cell over here. And now we have even 1 more cage added to the list. Let's make it yellow. This one will also be 8 different cells. We know the 1 will be in one of these 2 cells in box 4. And let's have a look at row 3 maybe. Where can the 1 be in row 3? It cannot be here, because it already sees the 1. Neither of these 2, because they're cages. There can be one in this one. And then it sees these 3 ones, these 3 cells, the 1 in this cell. So there will be 1 in either of these 2 cells. Now let's have a look at the yellow cage. We know for a fact this cell or this cage can never go to any row above it, because we have the sum in the leftmost of the highest row. So this one, it can also never go like all the way back up in some way. So now we know we need 8 cells. We cannot go up, and we cannot completely go down either. Because if we are going down, we got 5 cells here, then we have a 1 in the cage. It needs to be in either of these 2 cells. So we can maximum go 4 cells, or 2 cells down at least. Which means that at least 6 of these cells up here need to be in the cage. So we got 1, 2, 3, 4, 5, 6. Which means the 1 cannot be here. The 1 will be in this cell over here. Now we also know we cannot go into this cell, so we know it needs to go down the remaining 2 cells. So the 1 will be in this cell up here. Now let's have a look at the remaining ones. It will be in these 4 cells up here, but if we put a 1 here in this little cell up here, where will the 1 be in box 1? It already sees the ones from over here, sees the one from over here, sees the one from up here, but it also sees the 1 because it's a Renban line. We know it needs to be different digits, so there can never be a 1 in box 1. So we know it cannot be on the Renban line. It needs to be in these 2 cells instead. Now this one will be a 2, needs to be consecutive with the 1. This one will never be a 2. We know for this Renban line there needs to be a 2, so it needs to be down here. Now for this red band line, we know the 2 cannot be here, and we already have, for this cage, it contains the 2, so the 2 can never be here. 2 will be in this cell up here. Are there any more 2s we can get? For the green cage, where will the 2 be in that cage? The 2 sees those fields here. This 2 sees these fields here. This one can never be a 2. This one needs to be the 2. So we have a 2 up here. Now for these 2, they see all of those fields. This one sees this field. This one sees this field based on the cage. So 2 needs to be here. These 2 sees up here, this one here. So there will be a 2 here. And now we get a red band down here. We already know there's a 1 on it. So remaining digits needs to be a 2, 3, 4, 5 pair. This field already sees a 3 and a 4. Cannot be a 3 and a 4. Can we place any more 2s? I'll be 2 in 8 of these cells, 2 in 8 of these cells. What about 1s? We have all the 1s already. Okay. Maybe let's have a look at the 3 and 4s. Let's just color this 3 in with a red. This one will be the green 3-4 pair. This one sees this 3-4 pair down here based on the red grid. So this one will be the red 3-4. This one will be the green 3-4. Does that do anything? At least the 2 in box 3 cannot be in NFTs, cannot be here. There needs to be a 2 in either of these 2 fields. So this one cannot be 2, so 2 needs to be up here. And now we have a new red band, which is a 3 and a 4 pair, because it needs to be consecutive. This one is also a new box. So let's have a look at this one. We know for a fact there will be one of the digits somewhere on this row. Or one of the digits in the cage. Because we need to have the sun. It needs to be in the leftmost, in the top row. So if this is not the leftmost one, we need to have something in either of these cells. So we know it will go at least like this. It will not cross into this cell over here. We cannot go down to the 1. We cannot cross down into this cell, so it needs to go to the left here. We know it doesn't go up here because it's caged off here. No, it doesn't go down to yellow. So we'll go one step further. And now this one is not a cage cell, it's the yellow cage. We know it goes up 1. So at least we have that for now. Now let's have a look at the green 3-4 in box 2. We know neither of those cells can be the green 3-4. And neither can the 2 blue cells over here, because it sees the 3 and the 4. If this is a red and a green, or if it's the opposite, the green and the red, they can never be a 3 and a 4 over here. So we know the green 3-4 needs to be in this cell down here. Which also means it cannot be here, here, Needs to be need of these two fields, the green 3-4. Mm. Let's see. Maybe let's have a look at the red 3-4 and box 5. Cannot be here because it's in the red cage. Cannot be here because of this red one. So it will be in either of these two fields. Ah, here we go. Green 3-4. Where will this one be in row 7? These two are already occupied. We already have one for the red cage, so it cannot be in this field. It already sees the green in all of these three fields. Neither of these two fields can be the green 3-4, because we know these 4 digits contain 2, 3, 4, and 5. So this one up here will be the green 3-4 pair. And now let's have a look at the orange cage. Where will the green 3-4 be in this cage? Cannot be in either of these 5 cells. So it will need to be in one of these 3 cells, not this one of course, but so it will be in either of these two cells, which means this one up here needs to be the red 3-4, this one will need to be the green 3-4. Where does that take us? So the red 3-4 in the orange cage cannot be in any of those fields. Cannot be in this field because of this one. So it will be in one of these two, which means where will it go in box 8? Cannot go in any of these 3. Cannot go in any of those 2. Those 3 4s are seeing those fields. So it's only this single field that can be a red 3-4, which means this one can never be a red 3-4. It's in the green cage. We cannot have same digits multiple times. This one will be a red 3-4. Now let's have a look at the red 3-4 in box 6. Cannot be in these 3 fields based on the other red 3-4. None of these 2 based on this one. And this green cage sees this one. So it'll be in one of these 2, which means we have 3 and 4 of the green and the red. So this one will never be 3-4. This one will be a 2-5 pair. This one will be the red 3-4 pair. Now for the 5 in box 6. In the orange cage, it already sees the 5s. These 3 fields sees the 5s, so there'll be a 5 in this field over here. In box 3, 5 sees up here. These fields are seen by the other 5, so the 5 can only go in this field over here. Now for the yellow cage, none of those cells can be a 5. 5 will be in the remaining cell. Now let's see box 5. 5 in box 5. Neither of those. Green cage already seen. It will be in the red cage right here. Let's see. 2 still down here somewhere. Can we get some more 3-4 pairs maybe? For this one, the red 3-4. No. Ah, we're missing one digit in the pink cage. We know it needs to either go up to the 3-4 up here, or needs to go down to the cell down here. But we know it doesn't go up to the 3-4 up here, because the red 3-4 in box 6 needs to be in either of these two cells. We cannot have same digit multiple times, so it will never go up here, it will go down here. So this will be the cage for the pink, which means where will the 5 be in this cage? Not in those fields, not in this field. 5 will be in one of these fields, which means box 2, 5 sees this one, sees the 5 from here, it will be up here. And now we have the blue cage will go into this one. Is that all 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So now, where are we missing? We know neither of these two cells can be a 5. The 5 needs to be in one of these two cells over here, and the 5, because of this 5 up here, needs to be in one of these 4 cells over here. So if there's a 5 in this cell, for example, needs to be in 5 in this cell. We can never have a 5 in either of these two cells. Same goes for any of these other cells. We already have a 5 over here, so we need to have a 5 in this cell. Now we have a new red band line up here. And a new cage also. Let's make this one black maybe. Needs to be 8 cells. We have 4, 5, 6, 7, 8. Because it cannot cross into this cage, the yellow cage. This one is not a cage cell, it can never be a 1. So it needs to be like that. So let's have a look at the red 3-4s. It needs to be a red 3-4 in any of these two cells up here, which means this one cannot be a red 3-4. These two sees the remaining digits, so this one will be a red 3-4, which means the red 3-4 appears over in this corner. Where can the green 3-4 be over here? Not here, not here, in one of these 3 fields. Can it be here? Say this is a 4. Neither of these cells can be a 5, neither of these cells can be a 3, so we cannot have any consecutive digits. There needs to be a 3, a green 3-4 in one of these two, which means it cannot be here. This one sees over here. The green from the yellow cage sees this one. The green from the red cage sees this one. This one will be the red, the green 3-4 pair, which means this one up here will be the green 3-4. And now we can say this one is the green 3-4 based on these 3 fields. The green 3-4 in box 7 will be down here. The red 3-4 in box 6 will be here based on these two. Do we have all the 3-4s? Yep. Let's have a look at 5 in box 1. Cannot be here, 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 or the red. So this one will be a 5. Now we have a new red band line out here. So now we know the red 3-4 will be the 4, because if this was a 3, where would we have the 4 to be consecutive digits? Neither of these three fields can be the green 4. So this one will always be the 4, the green will be the 3. Let's just remove the coloring from these two. Now we know this one will be a 6, 7, 8 pair, because it needs to be consecutive. It cannot have a 3, so it needs to go 4, 5, 6, 7, 8. Now this one needs to be a 9, because see it's the 6, 7, and 8 from here, and all the 1, 2, 3, 4, 5. This one is a 9. And now we also know the red cage will end up in this cell over here. We know the 9 will be in one of these two cells, which means the 9 cannot be in these cells, cannot be based on this 9, because the black cage cannot contain two 9s, it will not be here, so the 9 will be in this cell here. Now we know this one will be 6, 7, 8. This one will be 6, 7, and 8. These two in the red will be 6, 7, and 8. This one down here, 6, 7, and 8. Are there more 5s we can get? Maybe the 5 will be one of these, one of these. Let's see, let's see. Let's just make all of these. This will be a 6, 7, 8, 9. Pair in all of these. Same with these fields down here. This is the 9 over here. Let's just try to get all the 6, 7, 8, 9s out. And then we can probably do some coloring on these ones. I will just remove the... actually not for now. Let's just keep them here. So let's have a look at these three cells. We know they will be all different 6, 7, 8, 9s. Which means this one up here will be the blue one. It sees the red and the green already. We know the blue will be this one because it sees these three based on the green cage. So we will now have a blue in this cell up here. This one cannot be a 9 now. The blue in box 3 will be here. The blue in box 9 based on these two will be over here. The blue in box 6 here, it will be down here based on these three cells. The blue over here needs to go in this cell, which means this one needs to be the 9. The blue goes down here. It sees those 4 cells. This one cannot be a 9 now because of this 9. This one needs to be the 9. And now there's a red band down here, a little pink line. We know the red in box 5 needs to go in this cell. Does it give any more? This one needs to be the green. For the yellow cage, it sees the blue and the red. We only have the green left. Which means this one needs to be the red, this one needs to be the green. This one down here will be the red. So we have the we have the green somewhere down here. somewhere here. This one will be green and red. This one is green and red. So we know this one will be a 9. Let's see, it's the 6, 7, and 8 here. This one is 9. This one is now the red one. It cannot be a 9 anymore. The 9 will be up here. This one is the green. This one is the red. This one will be red. These are green, red. These are green, red. Now we know this one needs to be consecutive to a 9. So blue and green needs to be 8 and 7. So the red one will always be 6. Let's just remove the 6 from these two. Also the remaining fields here. The blue cannot be an 8. Let's say this was an 8. Now we have this red band line down here by the orange cage. It needs to go at least one down, and it can maximum go one to the left, but we need at least an 8 in one of these ones. It needs to be consecutive with the 9. If this was an 8, there will be a 6, 7 pair here, and 9, 6, 7 or 9, 7 is not consecutive. So this one will always be 7, this one will always be 8. Let's just remove the coloring from these ones. You can see the 9 here. And now we know this rain band here can only go down 1. It cannot go down to the left because it doesn't have any consecutive 7s. This one would be an 8, this one would be a 6. So same up here. Now we have a 5, 8 over here, 2, 8, 9 here. But we already have an 8 in this pink cage here. Neither of these will be 8. This will be 2, 9, and 9. There we go. That was the ending of 44 and the ending of Artisanal Sudoku, volume 232.